Good morning. Today we will discuss what is Serial Peripheral Interface. In short, this is known as SPI. Before knowing what is Serial Peripheral Interface, let us study which are the different types of systems or communication system which are existing in embedded communication system. There are three main types of embedded system communication. One is based on the interconnect, second one is based on model, and the third one is based on bit transfer, in which we have two types of communication system, serial communication and parallel communication. We'll be mostly concentrating on serial communication. Data can be transmitted between a sender and a receiver in two main ways, serially or either parallelly. Serial communication is a method of transferring one bit at a time through a medium, whereas parallel communication system is the method of transferring blocks of data. For example, in the case of bytes, together it will be transferred. We will study what is the main importance of serial communication. We go for serial communication for many of the advantages. Some of them are, in serial communication it uses only one IO pin, whereas parallel communication uses more than one, that is nothing but 8 parallel IO pins. Most of the personal computer have serial interface to connect to its peripheral. Most of the common embedded system peripherals also, such as ADC, DAC, LCD and temperature sensor, also supports serial communication. So most of the time we go for serial communication system. There are different methods of serial communication. The main two are asynchronous communication, the other one is synchronous communication. In case of asynchronous communication, the data is transferred single byte at a time, whereas synchronous communication, it transfers block of data at a time. Asynchronous communication operate at same frequency but have two separate clocks, whereas synchronous communication operate at same clock. There are different modes of serial communication. Simplex mode and duplex mode are the two types. In case of simplex mode, data can be only sent. The best example for this one is TV and a remote communication. In case of duplex mode, data can be transmitted as well as received, in which we have two types, half duplex, full duplex. Half duplex, the data can be transmitted only one way at a time. Example is walkie-talkie. In case of full duplex, data can go both the ways at the same time. For example, the human communication or the human communication on the phone. Serial Peripheral Interface Bus or SPI bus is the asynchronous serial data link standard named by Motorola that operates in full duplex mode. Devices communicate in master and slave mode, where the master device initiates the data frame. Multiple slave devices are followed with the individual slave select lines. Sometimes SPI is called 4-wire system. SPI system also works, that is sometimes SPI, as I said, it is 4-wire system contrasting with 3 or 2 lines. There is a protocol of SPI system. The SPI bus specifies 4 logic signals. One is serial clock, which is nothing but the output from the master out, slave input, output from the master, then master input, slave output, output from the master, slave again, and the last one is slave select, that is active lower output from master. There are different types of resistors which are there in SPI, mainly SPI control resistor, status and control resistor and data resistor, and these three resistors can be configured according to the application. To begin a communication, the bus master first configures the clock using a frequency less than or equal to maximum frequency the slave device supports. Such frequencies are commonly in the range of 1 to 100 MHz. The master then transmits the logic 0 for the desired chip over the chip select line. Logic 0 is transmitted because the chip select line is active low, meaning its output is a logic 1. On is asserted with a logic 0. If a waiting period is required, then the master must wait for at least that period of time before starting to issue clock cycle. There are different advantages and disadvantages of this type. The advantages are, it is fast and easy. And the other advantage is everyone supports it. The disadvantages here are slave select makes the multiple slaves very complicated, no acknowledgement ability. The third disadvantage is inherent arbitration, and the fourth disadvantage is no flow control. So because of some advantages and disadvantages, we can go for either for serial and parallel communication. There are different uses. Some serial encoders, decoders, converter and serial LCDs and sensors uses this type of communication. Pre-SPI serial devices also use this type of communication. PPC implements SPI very well. The bus of choice for communication is also important. Thank you.